Okay, here we are in chapter 6 with test hint number 12 that says the lanthanide and actinide series. Again, series, same as periods, and the lanthanide and actinide series are the ones that start with the element lanthanum and the element actinium. That happen to be right there. Some tables put them in a different location. A lot of the ones we have in the room happen to put them up here in the body of the table. But remember, that's where you zoom down to the 4F and 5F. So the lanthanide series is the 4F, and the actinide series is the 5F. Right. They're just named for the element that starts them off.
Right. Lanthanum, element number 57, and then you jump down here to 58.
Right. Okay, number 12?
13, the periodic law. Periodic law, define the periodic law. You need to know how that works.
Right.
When the elements are arranged by order of increasing atomic number, periodic trends become apparent in their physical and chemical properties.
Right.
So, atomic radius, density, ionization energy, electron affinity, all of those things that we looked at here during class, those patterns, up, down, up, down, up, down.
Right. And we saw it like with the straws and the charts that are in like 3D format.
Do you see those patterns, up, down, when you put them in alphabetical order?
No.
No. They have to be in atomic number order. Number 14. 14.
The test hint says the number of protons and electrons in a neutral atom when given examples. Now you guys know this. The protons and the electrons have to be the same number if the atom is neutral. So we'll give you in this question several different examples of elements, and you just need to make sure that the protons and electron numbers match and that they're the right atomic number for the particular element. So we wouldn't say carbon 612, 6 protons, 12 electrons, because that wouldn't balance out.
Right.
But we would say carbon 6 protons, 6 electrons.
6 electrons.
So an answer choice like that. That one should be really pretty straightforward.
Number 15.
Yep.
What groups or columns, both verticals, what groups or columns represent on the periodic table? Well, they represent, sometimes we call these families of elements, because they have very similar properties. And for example, oxygen's family behaves in a very particular way. Or the halogen family, they have a very similar, predictable chemical behavior.
What is it that makes that happen?
I think it's valence electrons.
Yes, I'm so glad to know that you think.
Yes, which valence electrons are always a safe guess.
Yeah, because valence electrons most important thing in chemistry.
Yeah, so for example, the halogens, they all have 7 valence electrons. So they're all going to go through those same kinds of chemical reactions. Back at the very, very beginning of this chapter, we worked with lithium, sodium, potassium.
Right.
1 valence electron, very similar chemical reaction.
Right. So their electron configurations were ending in the same symbol, S1.
Right. S1.
For alkalis, P5 for the halogens, and so on. You guys are really pretty good at that after doing the flip stuff we did in the last chapter. All right, 16?
16, yeah.
The alkali metals. Well, you need to know where the alkali metals are on the periodic table. Column number 1, we've done a lot with them. You've seen them in video, you've seen them in live action, you've seen them on the laser disc, you've seen them on YouTube, you've seen them here. They're the ones that fizz and explode, shoot out flames when they are in contact with water. You should be able to identify them by name.
And then 17 is the halogens, which we're just kind of stepping all over these test hints. These are your halogens. Your halogens are very reactive, colored gases, they're all poisonous, and so on, going down there with 7 valence electrons. You should know exactly where to find them. It's either group 17 or 7A, and you should know by name.
Right, now you said they're very reactive, and we know those alkali metals in column 1 are very reactive, but these are very reactive non-metals. And it's not just, the non-metals are not all like the noble gases that don't really react very much for all intents and purposes. There are some very reactive non-metals, and halogens are an example of those.
Right.
All right, 18, you need to flip the page, Mr. Sussman.
Oh, sorry.
What is similar about all the electron configurations in the noble gas. You know what? It's like we knew this question was coming because we keep mentioning this kind of stuff. The noble gas elements at the end of a period have filled their s and p orbitals, so their configuration is going to be s2p6. That p6 configuration is the most stable, got 8 electrons in the outer shell. The octet makes them less reactive or non-reactive.
With one exception.
Yeah.
Well, all of these guys, neon, argon, krypton, xenon, and radon, they all end S2P6.
Yes.
Helium, just S2.
Mm-hmm.
Its only energy level is that little teeny tiny
Right.
1s, and that's all it can hold.
Right.
The point is that valence energy level is full.
Yes. Alrighty, number 19.
Number 19, what subatomic particle determines an atom's properties?
My favorite one.
And again, I'm going to guess valence electrons.
Yep, electrons, valence shell. Remember, the protons are what makes the atom what it is, the element what it is, what kind, but the electrons are what tells us about its behavior, its personality, maybe if we wanted to anthropomorphize.
Yes.
The
When two atoms bump into each other, it's only the outer surface of their electron clouds that bump into each other.
Right, not the nucleus.
Right. Nucleus doesn't even know what's going on half the time. So it's those valence electrons that determine all those chemical properties.
Right. Alrighty, number 20. What type of elements are in the D block of the periodic table? Well, that goes back to our example over here. And just the general characteristics of the elements. You know where the D block is. And you know that most of the elements on the periodic table are metals. We call the D block elements the transition metals. And we know that their properties are not quite as dramatic and exciting or reactive as, say, the column 1 or 2 elements. But those are metals. Pretty straightforward. 21.
21. Where the metalloids are? Well, they're right here, smiling at you on that stair-step line. The stair-step line, the zigzag line, that boundary line between the metals and the non-metals. There they are. You just have to be able to find that line.
Right. And they have properties that are in between metals and non-metals, so there's kind of that gradation from the really reactive things on one end to less reactive, and then, okay, now we're starting to have some different characteristics.
I'm not sure if this is a metal or non-metal.
Okay. 22. Endings in electron configurations for specific groups. So that's our test hint. Endings in electron configurations for specific groups. You need to remember that the groups are columns. They go up and down. And really, just look at the last thing you would write for a configuration. If you're in column 16, you're going to end in blah, 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 P4. If you're in column 18, it's blah, 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 P6. If you're in column 13, it's S2P1. Okay? Find things with similar configurations in the same column.